Hello. Today, I would like to talk about how the garbage collector works in Java, Python, and Go. Part 3. This video is only 5 minutes, but the content is very difficult and complicated, so my understanding is slow. Okay, let's try to understand from 3 minutes, 5 seconds mark. Ideally, I hope finish mm, until the end. But keep in mind, be carefully try to understand. Today, I'm focusing on breakdown and mm, catch the meaning and mm, remove my question. Let's dive right in.
Languages take different approaches to garbage collection. Java, for instance, offers several GC algorithms: serial, parallel, CMS, and G1. The evolution of these algorithms reflects the need to balance performance, latency, and scalability
Performance,
across different
latency,
application types.
scalability,
They are designed to
trade-offs.
handle everything from small-scale apps to massive enterprise systems, often using a generational model to optimize performance. Python uses a combination of reference counting and a cyclic garbage collector. The reference counting handles most cases by automatically deallocating objects when their reference count drops to 0. The cyclic collector cleans up circular references, which reference counting alone can manage. Go uses a concurrent mark and sweep collector, which operates alongside the application to minimize pause times.
GoGC, garbage collector. Root node, go to A, B, and D, and heap root, stack root, unscan or reachable is white, active is black, reachable is gray.
It leverages a tricolor marking algorithm
Tricolor marking algorithm.
mentioned before to handle reachability efficiently. This
Hmm.
allows garbage collection to proceed incrementally without significantly disrupting application performance.
Disrupting application
As helpful
performance.
as garbage collection is not without drawbacks. For one, there's the performance overhead. GC cycles can introduce unpredictable pauses, which might not matter for some applications, but could be a problem for latency-sensitive systems. There's also memory fragmentation. Some collectors leave gaps in memory, making allocation slower over time.
Fragmented heap.
Memory management also involves balancing used pool and free pools to ensure efficient allocation and deallocation without fragmentation. With garbage collection, we usually lose fine-grained control over when cleanup happens. This can lead to unpredictable pauses in your application. If you like our video, you might like our system design newsletter as well. It covers topics and trends in
Yeah, latter part is also difficult. It explained Java and Python and Go garbage collect. How does it works? One is mark and sweep algorithm. Uh, in the, in other words, Go garbage collection is working in tricolor mark and sweep algorithm, which is more better than normal previous mark and sweep algorithm. Hmm. As helpful as garbage collection is not without drawbacks. Hmm. Maybe last part, uh, he explained about drawbacks of garbage collection. Hmm. Okay, so each sentence, let's break down the meaning.
Traced at once. Languages take different approaches to garbage collection.
Languages take different approaches to garbage collection. Hmm. Language take different approaches, so use different approaches to garbage collection.
Java, for instance, offers
Java, for
several
instance,
GC
offers
algorithms:
several GC
serial,
algorithms, serial,
parallel,
parallel,
CMS, and
CMS,
G1.
and G1. This is hmm, serial, parallel, CMS, G1 is GC algorithm. Hmm.
The evolution of these algorithms reflects the need to balance performance,
The evolution of these algorithms reflects the need to balance performance,
latency, and
latency, and
scalability across
scalability
different
across
application
different
types.
application types. The evolution of these algorithms reflects the need to balance performance, latency, and scalability across different application types. Mm, what is the subject? Subject is the evolution of these algorithms reflects. Object is the need to balance performance, latency, and scalability across different application types. Mm, the need to balance performance, latency, and scalability. はい、ChatGPT. Could you tell me this sentence meaning? The evolution of these algorithms reflects the need to balance performance, latency, and scalability across different application types.
Sure, that sentence means that over time, these algorithms have changed or improved to address the challenge of balancing three key factors: performance, latency, and scalability, depending on the type of application. In other words, as the needs of different applications vary, the algorithms have evolved to ensure they can handle these factors effectively.
Mhm. Sorry, Could you tell me one more time and more simply, more easily?
Of course, it means that these algorithms have changed over time to find a good balance between speed, quick response, and the ability to handle growth, depending on what each application needs.
The evolution of these algorithms reflects the need to balance performance, latency, and scalability. So, and what's me across?
Across in this context means for different or among different. So the sentence is saying that the balance of performance, latency, and scalability needs to be considered for different types of applications. In other words, the evolution of these algorithms shows how important it is to find that balance for various kinds of applications.
Across means among.
Exactly. Across here is similar to among or for different, highlighting that the balance applies to various types of applications.
Okay, next.
Nope.
They're designed to handle everything from small-scale apps to massive enterprise systems.
They are designed to handle everything from small-scale apps to massive enterprise systems,
Often using a
often using
generational
a
model
generational
to
model
optimize
to
performance.
optimize performance. They are designed to handle everything from small-scale apps to massive enterprise systems, often using a generational model to optimize performance. Often using a generational model to optimize performance. They. What's mean they? They. They is the evolution of these algorithms. These algorithms are designed to handle everything from small scale apps to massive enterprise systems. So every system, often using a generational model to optimize performance. Mm. So what's the generational model? Uh, Earlier we mentioned generational model means generational hierarchy. Young generation, old generation, metaspace. Hier- Hierarchy. Hierarchy. Next.
Python uses a combination of reference counting and a cyclic garbage collector.
Python uses a combination of references, counting, and a cycle garbage collector. How about Python? Uses a combination of reference counting and a cycle garbage collector. Hmm. New type of garbage collector, counting and a cycle garbage collector. Not a generational model, not a mark and sweep model.
The reference counting handles most cases by automatically deallocating objects when their reference count drops to 0.
The references counting handles most cases by automatically deallocating objects when their references count drops off to zero. The references counting handles most cases. The references counting handles most cases. The references the references counting. The references counting is subject. Handles most cases by automatically deallocating object. Deallocate. Deallocate.
Deallocating.
Deallocating. So, release the memory. So, reclaiming. Deallocating objects when their references count drops to zero.
By automatically deallocating objects when their reference count drops to zero. The cyclic collector cleans up circular references.
The cycle corrector cleans up cycle references.
Which reference counting alone
Which references
can manage.
counting alone can't manage. Which references cycle corrector clean up circular references. Circular references. Which references counting alone can't manage. Which references counting alone can't manage. What's mean this? What mean this sentence? The cycle corrector cleans up circular references, which references counting alone can't manage.
This sentence means that a special part of the garbage collector, called the cycle collector, takes care of removing objects that reference each other in a loop. These loops are something that simple reference counting alone can't handle, so the cycle collector steps in to clean them up and free the memory. You're welcome.
What mean references counting?
Reference counting is a memory management technique where each object keeps track of how many references point to it. When a reference to an object is created, the count goes up, and when a reference is removed, the count goes down. Once the count drops to zero, meaning no references point to that object, the object can be safely deleted because it's no longer needed. This helps manage memory by automatically freeing up space that is no longer in use.
Reference counting is a memory management technique. Memory management technique. Where each object keep track of how many references point to it. When the reference to an object is created, the count goes up, and when the reference is removed, the count goes down. Once the count drops to zero, the object can be safely deleted because it's no longer needed. This helps manage memory by automatically freeing up space that is no longer in use.
Uses a concurrent mark and sweep collector, which alone can manage. Go uses a concurrent mark and sweep collector, which operates alongside the application to minimize pause times.
Go uses a concurrent mark and sweep collector, which operates alongside the application to minimize pause times. Concurrent mark and sweep collector, which operates alongside the application to minimize pause times. Alongside. Operates alongside the application to minimize pause times.
Alongside.
Alongside, which is same meaning of alongside, along. What is different between along and alongside?
Alone means by itself or without anything else. For example, if something is alone,
No, not along and alongside.
got it. Along and alongside both refer to something being next to or together with something else, but there's a slight difference in how they're used. Along typically means moving or extending in a line next to something. For example, we walked along the river means you moved parallel to the river. Alongside specifically means right next to or side by side with something. For example, she worked alongside her colleagues means she worked right next to them or together with them. In short, along often refers to moving or extending in a direction, while alongside emphasizes being right next to something.
Along often refers to moving or extending in direction, while alongside emphasizes being right next to something.
It leverages a tricolor marking algorithm mentioned before to handle reachability efficiently.
It leverages a tricolor marking algorithm mentioned before to handle reachability efficiently.
This allows garbage collection to
garbage
proceed
collection.
incrementally without significantly disrupting application performance.
This allows garbage collection to proceed incrementally without significantly disrupting application performance. Without significantly disrupt application performance, this allows garbage collection to proceed incrementally. Without significantly disrupting means great lose application performance. Without losing performance, without slow performance, this means tricolor marking algorithm. Tricolor marking algorithm allows garbage collection to proceed incrementally.
As helpful as garbage collection is not without drawbacks.
As helpless, as helpful as garbage collection is, it's not without drawbacks. Hmm, it's not without drawbacks. What means this sentence? As helpful as garbage collection is, it's not without drawbacks.
This sentence means that although garbage collection is very useful, it also has some disadvantages. In other words,
Also, garbage collection is very useful. It also has some disadvantage. As helpful as garbage collection is, it's not without drawbacks. What what's this what this structure? I'm not sure about how to use this grammar.
this structure is called a concessive clause. It's used to show that even though one thing is true, there's a contrasting point. The pattern is as helpful as garbage collection is, followed by the contrasting statement. In this case, as helpful as garbage collection is, means even though garbage collection is helpful, the second part, it's not without drawbacks, presents the contrasting idea that it has some downsides. You can use this structure to highlight a positive aspect while acknowledging a downside. For example, as convenient as it is to work from home, it can be distracting.
Hmm. So, as helpful as garbage collector is means even though. Why Why even though? Even though means negative meaning, I think. But uh,
I get what you mean. Even though doesn't necessarily imply something negative, it just introduces a contrast or a concession. In this sentence, it's pointing out that although garbage collection has a positive aspect, it's helpful, there's also something not so great about it. It has drawbacks. So even though here is used to show that despite the positive, helpfulness, there's still a contrasting point, drawbacks. It's a common way to express a balanced view.
I'm confused to hear not without drawbacks because not is negative and without is negative and drawbacks is negative. So what's the result? As a result, this sentence means mm, negative, actually.
I see where the confusion comes from. The phrase not without drawbacks is a common way to say that something does have some disadvantages. It might sound complicated because of the double negatives, but it's essentially saying it has some drawbacks. So even though not and without are both negatives, they combine in this phrase to mean that there are indeed some downsides. It's a subtle way of acknowledging that something isn't perfect. So in the end, the sentence is just noting that garbage collection, while helpful, has some downsides.
Mm, yeah. Mm, I think even though, even though, mm, sorry, wait a minute. Uh, I think even though it is helpful, but it has drawbacks. This sentence is very easy to understand, but does why did they use such a complicated sentence?
That's a great observation. Sometimes writers use more complex structures to sound more formal or sophisticated. Phrases like not without drawbacks are often used in writing to convey a nuanced or balanced viewpoint. It's a way to sound a bit more polished or to emphasize that something isn't entirely perfect without being too blunt. In conversation or simpler writing, it's definitely clearer to say, even though it's helpful, it has drawbacks. The more complex phrasing is just a style choice to add a certain tone or emphasis.
For one, there's the performance
For one,
overhead.
there's
GC
performance
cycles can
overhead.
introduce
GC
unpredictable
cycles can
pauses, which
introduce
might not matter for some applications, but could be a problem for latency-sensitive systems.
GC cycles can introduce unpredictable pauses, which might not matter for some applications, but could be a problem for latency-sensitive systems. There's also memory
There's
fragmentation.
also memory fragmentation.
There's also memory fragmentation. Memory fragmentation.
Fragmentation.
Fragmentation. Memory fragmentation. Memory fragmentation means a lot of small memory. Around the around the server.
Some collectors leave gaps in memory,
Some
making
characters
allocations
leave gap
slower
in
over
memory,
time.
making allocations slower over time.
Memory management also
Memory
involves
management
balancing
also
used
involves
pool and
balancing
free
used
pools
pool
to ensure
and free
efficient
pools to
allocation and
ensure
deallocation without
efficient allocation
fragmentation.
and
For garbage
deallocation
collection,
without
we usually
fragmentation.
lose
With
fine-grained
garbage
control
collection,
over
we
when
usually
cleanup
lose
happens. This can
fine-grained
lead to
control over
unpredictable
when cleanup happens.
pauses in your application.
This can lead to unpredictable pause in your application. Some collection leave gaps in memory, making allocations slower over time. Memory management also involves balancing used pools and free pools to ensure efficient allocation and deallocation without fragmentation. With garbage collection, we usually lose fine-grained control over when cleanup happens. Ah, it is too hard to understand. It's very difficult to break down because uh, um, technical specific words are a lot, and for example, fragmentation and fine-grained controls and used pools, free pools. Okay, time up. Today's part is also difficult, but even though I takes over time, but I try to find, I try to, I try to organize my knowledge of this topic. Thank you for watching. See you by next time. Bye bye.